Hello everyone, welcome to my channel on learning field. Today in this topic we'll discuss about the Gauss law. Gauss law states that the total flux of the electric field E over any closed surface is equal to the times the net charge enclosed by the surface. That means electric flux E is equals to charge by epsilon naught. This is the meaning of the 2 times the net charge enclosed by the surface, that means 1 by epsilon naught. Okay, and Gauss law also relates the flux through any closed surface. That means Gauss law is only applicable in closed surface. If it is not closed surface, suppose Gauss law does not have any application, that means it does not exist. So, Gauss law relates the flux to any closed surface and the net charge enclosed within the surface. So, Gauss law help us to find the net charge enclosed within the surface, and it relates only in a closed surface. This one is the main application of Gauss law. Okay, and it already states that it is the total number of electric field E over in closed surface is equal to the times the net charge is equal to the times the net charge enclosed by the surface. Okay, now uh, a closed that means the closed imaginary surface is called Gaussian surface. I have already told you that Gauss law is only applicable in closed imaginary surface. Closed imaginary surface means is called the Gauss law. Since you have studied in the formula directly, I think today we'll derive the formula. Application of Gauss law. Number 1, electric field due to an infinite long straight charged wire. Now let us draw the diagram. I have drawn roughly. Please try to draw it very nicely in your copy. It has plus q charge and the length of the surface is L, and the circumference is 2 pi r. Note down this one. And uh, suppose the radius is r. Suppose the radius is r. Then we came to know that after finding the length, radius, and we need to consider a small distance. So let us consider a small distance ds vector, and suppose we need to write here this is radius r, and this is distance, suppose this is distance ds vector, and electric field is also acting here. So electric field is acting here. Suppose this is dipole moment p. Okay, now we know that electric field is acting on the surface. Now the consideration part you need to note down. So let us consider an uniformly charged wire, and uniformly charged wire of infinite length. That means the length of this wire is very infinite. That means it is unstoppable. Infinite length. Having a constant, that means linear charge density. Linear charge density. You also know that linear charge density means what? Lambda. We have learned from the previous derivation, isn't it? So if you have not watched that video, please watch it from the previous video, so to know the concept of this application of Gauss law. So linear charge density lambda, let p be the let p be a point, at a distance r. Distance r closed as closed not as close at each end, close at each end by plane caps. They are plane caps. Normal to axis is chosen as Gaussian surface. Gaussian surface means what? Gauss law. The surface is also known as Gaussian surface. So simple. Now the derivative part comes now. If you want to note this consideration part, you can note down very neatly and cleanly. Now, therefore, the flux phi through the current surface. Now, since we know that we need to apply here Gauss law, therefore to apply first Gauss law, we need to apply the formula of flux. Since the flux phi through the current surface, that means not current, it is curved surface. Okay, please correct this one, a little bit mistake is there. Not current, it is curved surface. Okay, curved surface, because this one is curved surface, we already know, isn't it? So it will be curved surface. Now curved surface will be equals to, since we know the formula of flux, isn't it? If you don't know, you can note down. We know that flux is denoted by symbol phi. This is rough work. Okay, you need to write down in rough. So phi is equals to EDS cos theta. Okay, why you have written cos theta? By removing this vector sign. We need to write the angle. Okay, that's why we have not written here vector. Okay, so you need to write integration of EDS cos theta. Therefore, we can write that phi is equals to close integration of EDS. Now here, what is the value of theta? If you know, since they are acting on the parallel line from the concept of class 11, since they are acting on the parallel line, then theta equals to 0. Then theta is equals to 0, isn't it? Theta is equals to 0 degree, then cos 0 degree will be equals to 1. Cos 0 degree is equals to 1. So you can write here just 1, or simply you can leave. Therefore we can write, now if you integrate this one, since I think you have not learned about integration till now, or also if you have learned, then close integration of EDS will be equals to, this will come out, and in close integration of DS, ds means what? The surface, the length or surface. Closed integration of the surface, closed cylindrical surface equals to circumference, that means 2 pi r. Next line you need to write down. So E is equals to, that means phi is equals to E into 2 pi r l. Okay, now you need to write a little bit. Since examine carefully in the diagram, since electric field and ds are, examine carefully in the diagram, since this electric field E and the distance ds are acting perpendicular, isn't it? They're acting perpendicular. You can see this one, they are acting perpendicular. So we can write they are right angles to each other. Then the electric flux through the plane caps since electric field and this length ds are right angles to each other, then the electric flux through the plane caps will be equals to, since they are at right angles, then we can say that they are is equals to 0. Okay, therefore the total flux through the through the Gaussian surface phi is equals to E into 2 pi r l. Okay, now the next you need to write that therefore the net charge enclosed by the Gaussian surface is, no, you need to find the charge. Since our main aim is to find the charge, isn't it? From before we are aiming to find charge. So now we can find out the value of charge, and by applying the Gauss law we can find it easily, we can derive it easily. So q will be equals to what? Now one formula you need to remember, since linear charge density lambda is equals to q by l, we know, isn't it? Q by l. If you cross multiply this one, then you can see that q is equals to lambda into l. This is rough word, okay? Just to explain you, I have written this one, so you can write in the rough copy q is equals to lambda into l. So q is equals to lambda into l. According to Gaussian law, now apply the formula and get the result. According to Gauss law, we know that we have already learned the Gauss law states that we have already learned, isn't it? Here look at the diagram carefully. Gauss law states that the total flux of the electric field E over any closed surface is equal to the times the net charge enclosed by the surface. Okay, Suppose we have considered a charge of plus q. This is plus q charge, isn't it? Net charge enclosed by the surface. Formula of Gauss law I have already explained you. Phi is equals to q by epsilon naught. So this is also rough. Now directly you can write down, directly by applying the formula you can note down that since we have found the value of phi, so phi is equals to what? E into 2 pi rl, and lambda into l, lambda into l, q, the value of q, lambda into l, and epsilon naught will be here, isn't it? Since our main aim to is find the electric field, so by cross multiplying you can note down that electric field is equals to, by cross multiplying, this one will go here and this one will go here by cross multiplying. Okay, lambda by 2 pi r epsilon naught. So easy derivation, hence proved, or you can say hence, or you can say hence proof, or hence derived. Okay,